Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 101, Symmetric Tree. In this video, we are going to explain a solution based on recursion. So the reason we present a solution based on recursion first is due to the fact that binary tree is a recursive abstract data structure. So for this problem, the statement is very short. So basically, given the root of a binary tree, we are required to return whether it's a mirror of itself. In other words, it's symmetric around its center. So here are two examples. In example 1, so the return is true. You can view this using this vertical dashed line as a mirror. So in example 2, because the two leaves are not mirror symmetric, therefore the return is false. The constraints for this problem is the following. First, the number of nodes in the tree is in the range given by 1 and 1000. Secondly, the value of the nodes is are in between -100 and +100. So the -100 and +100 is not this range. In other words, is not that essential for this problem. So with that said, let's look at the treatment. So here, what I want to do in this problem is first I'm going to write a inner function or a method. Let me write a method here. So check if it's a mirror of two trees. So let's see. Given two binary trees, I want to check if there are mirror images of each other. So then I want to use this method, apply this method to our problem. So this is going to accept two tree nodes or two tree node objects, and then the return is a boolean, right? And basically it checks if left and right, the two trees are mirror images. So assume we have this method. So basically what we are going to do is the following. If not root, so in other words, this is null tree, so we're going to return true. Otherwise, so because the root is not null, so we can call it left and right, then we can call this method. So we're going to return self is mirror, root left and root right. Then this is going to give us what we need. So here, let's focus on how to write this is mirror method. So for now, this one, so this is actually very straightforward. The thing is that, so we practice quite a large number of such problems related to binary trees or in more general graphs. So first, I'm going to check a stop condition or a base case if not left and not right. So in other words, both left and right are null trees. So in this case, we are going to return true. So after this if check, the complementary is that either left or right. So at least one of them is not null. So let's make this check. If not left or not right. So in other words, this condition, after we do the first if check, it means one of them is null. But we know the other is not null, so we are going to return false. Next, we are going to deal with the case that both left and right are not null. So in this case, in order for them to be mirror symmetry images of each other, first we need the value at the roots should be the same, right? So basically we want to check if left value equals, let's say do this, does not equals to right value, right? So in this case we just return false, right? So otherwise, so the values are the same. We need to check the corresponding subtrees. For example, here if we look at 2 and 2 here, so we want this 3, that is the left subtree of 2 should be the same as the right subtree of this 2. Similarly, the left subtree of this 2 should be, this is the right? The right subtree of this 2 should be the same as the left subtree of this two here. So what we are going to do, let's call this out. So basically its self is mirror. So what we are going to do is left is corresponding to right, and the in is going to be, let me change, let's use this one. Self is mirror. So left, right is going to correspond to right, left, right. So in order for them to be mirror images, we need both out and in, right? So this actually finished this method. As this method is finished, so this main method is also finished. So this piece of code forms a solution format to this easy but interesting question. So let's first do a check. Oh yeah, it passes one example. Now let's look at generic case. Yeah, it passes all the cases. So this is one solution format. If you like, so you can make this code an inner function. Let's see. Let me copy this part and put it here. And then let's call this solution v1. And then I'm going to make this one an inner function. I'm going to cut this one here, and then I put here. But let's delete this object call, right? So here, just call this function itself. And then I'm going to return this one. This is also legal, right? Let's do a check. And indentation, let's see, here. I guess I know it's here. Let's put it here. So should be okay. Yeah, it passes one example. Now let's look at generic case. Yeah, it passes all the generic cases. So with that done, I guess basically that's a solution based on recursion. So as in the description, can we try to solve it iteratively, right? So you can do this challenge. So in this video, we're going to stop here for presenting this recursion solution. So in a follow-up video, maybe we'll explain the iterative format. So personally, for me, I guess for this tree-related problem, it's good to first think of recursion. And then if you have time, maybe it's also good to try iterative format. So sometimes we feel that the iterative format reveals us more details, and actually it's a very good practice. So with that said, I guess that's about it for the video now. Thank you.